Hello and welcome to my YouTube channel. This is Sahil Ahamed along with Arnaa Burman and Soumyajit Maji from Adamas University BCA final year batch 2022 to 2025. In this video, I shall be explaining you our final year major project, which is a follow-up video of the minor project which I uploaded earlier. In this project, we shall be explaining you the work we did. So this is a research-based project such that we are planning to publish a research paper based on our project. In this project, we tried to integrate two domains of computer science, that is cybersecurity with machine learning or so-called AI. So the title of our project is Comprehensive Study of Anti-Detection Techniques in Windows Malware. In this project, we are trying to detect a special type of malware known as fileless malware, which is more difficult to be detected by anti-malware systems using machine learning classifiers. For this, as this is a research-based project, we have taken help from this journal article and this this master's thesis. So let me take you to the methodology of our project to make the things clear. So this is the methodology of our entire project as we are dealing with fileless malware. So we have detonated some fileless malwares and some benign files inside a virtual machine and have taken the memory dump, that is the actual RAM data, uh, and saved it into our local files. We have done this using a tool known as dump it tool, and these are the samples of the memory dumps. Each one is of nearly 2 GB. These are the samples of the benign files, and these are the samples of the malicious files. There are 16 malicious files and 24 benign files collected. The data source has been used from this particular master's thesis, this one. After that, if you see, after that, we have transformed those fileless malware memory dumps and benign memory dumps into images. For that, we have taken help of this Python tool known as binary to image. And these are the samples of the image conversion from the memory dumps. And we have converted two resolution images from a single memory dump file. So this is 112 into 112, and this is a sample of 56 into 56 of a single file. After that, we have used feature extraction methods. Uh, First one is AGCWD, and the second one is GIF, that is guided image filtering. So after applying AGCWD, the images changed into something like this. And after applying GIF on the AGCWD images, the images change to something like this. So these AGCWD and GIF were used to enhance the features of the images for machine learning classifiers to be identified or to be uh, 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 to work with ease. So after this, the total number of images we collected were 80. So this 80 images is not sufficient for a machine learning classifier to be identified to work with. The machine learning model shall overfit with this little sample of images. So for that, if you see, we used image rotation method to increase the number of data set in our process. So we converted every image into 8 possible directions to increase the number of images. So if you see, there are 8 possible rotations from a single image. After that, we converted those images, 640 images, into a .csv file by doing vector conversion. So for that, we used this methodology of vector conversion. We took the images and converted the images into 1D factor by doing dimensionality reduction and forming the pixel values and converting into vector transformation. So after that, we came up with two feature vectors, that is CSV files, that is of 112 into 112 dataset and 56 into 56 dataset. If I open the datasets, you can see the number of features and the number of files that have been captured. So this is a dataset of 112 into 112. There are nearly about 12,000 features for a single CSV file, along with the level. And if I scroll down, there are nearly about 321 rows in a single file. Similarly, for 56 into 56, if I open it, there are nearly about 3,000 features along with the label, and I guess 321, yes, 321 rows in a single CSV file. So after this vector conversion, we fed the CSV files into machine learning models. For choosing the machine learning models, we use the two research papers, the two papers which I showed you, and we came up with five different machine learning classifiers. So these are the machine learning classifiers collected from both the research papers, that is SVM, KNN, random forest decision tree, and XGBoost. As this is a comparative analysis of the fileless malware machine learning model, so we have trained the model with both the data sets 112 into 112 and 56 into 56, and these are the accuracy, precision, recall, F1 score of the entire five machine learning classifiers. So if I take you to this sheet, you can clearly see that this first research paper, we have taken only XGBoost from this paper, and for the rest of the models, we have chosen this master's thesis as a reference. So if you see, uh, these are the numerical values or the accuracy scores of the SVM from this paper, that is 0.56, but for our trained model, we came up with 0.70 accuracy. For KNN also, it was 62% accurate, but for our trained model with 56 into 56 or 112 into 112 trained dataset, the accuracy increased to 0.65. And for rest of the models, that is random forest, decision tree, and XGBoost, the performance downscaled. So this table clearly mentions how the models performed on 112 into 112 dataset and 56 into 56 dataset, and we only focused on the accuracy matrix for every machine learning classifier. So as I said, as this is a research project and a comparative analysis with the research paper I showed you, so we came up with these two machine learning classifiers, that is SVM and KNN, as an upscaled model as compared to the uh, machine learning classifiers used in the research papers. So this is the entire project we came up with, and we are planning to publish a research paper based on the outputs and results. So thank you for watching the video. See you until the next video.